If I multiply this by 2, I get 6. Multiply this by 2, I get 8. Multiply this by 2, I get 10. So 3, 4, 5, you can use many, many different multiples. I can go 9, 12, 15. Oh, we saw that in just this one. 9, 12, and R was 15. So the 3, 4, 5 is the simplest of the Pythagorean triples, and like I said, it's ubiquitous. So we can find the sine of the angle. Sine of the angle, if you remember the formula, was y over r, which is equal to 8 over 10, which turns out to be 3 over 5 if you reduce that. The cosine of the angle is equal to x over r. X, where is it? There it is. It's 6 over, the radius is 10, and reduces to 3 over 5. And, oh, that's wrong. Y. That's 8, sorry. Excuse me, it can't be the same. It must be 8 over 10. Going too fast, John? 4 over 5. Notice when I go too fast, guys, even for me, I trip up. So slow down on your work, okay? If every time I double my speed, I probably have an increased chance of probably 40%, 50% chance of getting more errors. So slow down when you're doing your homework. Tangent of the angle is going to be y over x. What's my y value? 8. What's my x value? 6. 8 over 6 is 4 over 3. So one of the first things I want you to do is write your x and y, find your r value first. Second, write your formulas down, and then answer what they want. Give them what they want. Your mom asks for milk and you give her water, she's going to look at you funny. Okay? I'm not going to do number 25 or 26 because it's the same process except you have to use a calculator. You might have to use some calculators. Let's do a couple of other problems. It says draw each of the following angles in standard position, find the point on the terminal side, and then find the sine, cosine, tangent of each angle. I'm going to la-di-da-di-da-di-da. So let's do one of these problems. 27. (135 degrees). That's your angle theta. In standard position, 135, this is quadrant 1, 2, 3, 4. It starts off at standard position. The initial side is 0. It's going to go positive. Let me use a different marker here, pen. It's going to go positive 135 degrees. There it is right there. Okay? So it's going to end up in quadrant 2 somewhere. And here's 135. And that's going to be theta hat. The hat, you're going to learn what a hat is later on. I'm going to use a different color. Orange doesn't seem to be very appealing sometimes. Theta hat right there. Theta hat is what's called a reference angle. We'll start talking about reference angles very soon, very fast. Okay, guys? But don't worry about that. It's 135 degrees. Obviously, this is going to be 180 minus that, or 45 degrees. So we know that theta hat, the reference angle, is 45 degrees. Find the point somewhere on the side. So here's the initial side. This is the terminating side, 135 degrees. We're going to find a point somewhere. So you have to do a little bit of work before you actually start. If this is 45 degrees, you have to go, I don't know, pick a point. Negative 4, you have to go up 4. It's going to be positive. Got it? So if you go negative, because it's a 45, 45, 90 degree triangle, if this is minus 4, that has to be positive 4. Or you could have picked negative 1, positive 1. It really doesn't matter which point you get, the ratio will always turn out to be the same. Like, let me say that again. The ratio of the sides are always going to be the same. Does that make sense? Hope so. We have to find out what R is. We know that on a 45, 45, 90 triangle, if this is x, x is in the x root 2. So this is 4, 4, 4 root 2. I'm going to use blue for this. So that's 4 radical 2. That's your R. I'm going to write in coordinate system, negative 4, comma 4. Here's your X, here's your Y. Negative 4, 4, that's that point right there. And it says, what does it say? I'm going to use my Mckeague marker, 27. Find the sine, cosine, and the tangent. So I want the sine of that angle, cosine of that angle, and the tangent of that angle. The sine of that angle, we know it's y over r right there. 4 over 4 radical 2. The 4's cancel, it becomes 1 over radical 2. Rationalizing the denominator, we should get root 2 over 2. Don't forget to learn to rationalize the denominator on this. Okay? What you can do is multiply top and bottom by root 2 over root 2. The cosine of the angle is equal to x over r. My x value is negative 4. My radius is going to be 4 root 2. These cancel, you get negative 1 over root 2. Multiply top and bottom by root 2 over root 2. You get negative root 2 over 2. Don't forget, if I multiply by root 2 times 2, root 2 is just 2 right here. And I'm sure you can find out, so that's the cosine. I'm sure you can find out what the tangent is. It's just y over x. Let me do that for you. Tangent of the angle is equal to y over x. Y over x is going to be negative 1. Terrible writing. Negative 1. Let me pull this down just a little bit. Negative 1. Okay, guys? Let's do some more difficult problems. Move this over just a little bit. This part gets a little bit more difficult. It's not that bad. Indicate the quadrants in which the terminal side, the ending side of data must lie in that order. So before we go over this, let's look at the quadrants right over here and the coordinates. We know that this is positive, positive, negative, positive, negative, negative, and positive, negative. Quadrant 1, quadrant 2, it goes counterclockwise, it's counterintuitive, starts off at standard position 0, going counterclockwise, that way it's going to be positive, counterintuitive. So, 35 says, what quadrant is the cosine of theta going to be positive? Quadrant, please. So cosine is equal to x over r. You have to look at this value x because r is always positive. So where value is this positive? In quadrant 1 and quadrant 4. You can draw it out every single time, but you want to try to figure it out in your head and see where the x value is positive. It's going to be quadrant 1, comma quadrant 2. Okay? That was number 35. Let's do something a little bit harder. Let's try 39. 40. Sine is positive. Sine of theta is greater than 0. Greater than 0 means it's positive. And cosine of theta is negative. Less than 0 means it's negative. So that means it's positive, and cosine of theta is negative. We're going to put our hand right there. The sine is the y value, right, over the radius. Radius is always positive. One is this positive, one is the y value positive. Question mark, or quadrants? It's going to be quadrant 1, comma 2. For this one right here, cosine is the x, because it's x over r. We're looking at the x value. One is it negative, or less than 0 right over here. It's going to be negative in quadrant 2, comma 3. And here, where do they overlap? 1, 2, 2, 3. It's going to be quadrant 2. Takes a little bit of practice. you can kind of see where it's going for a lot of these problems. Let's do some more problems. Find the remaining trigonometric functions if the sine of theta is 12 over 3, 13, and theta terminates in quadrant 1, yada 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 yada. So let's actually do 23 then. 43. One of the questions says the sine of theta is equal to 12 over 13, and theta terminates in quadrant 1. And you want to find cosine of theta equals the tangent of theta equals secant of theta equals, and cotangent of theta equals, and the cosecant of theta equals question mark. So that's, we want to find all 6. Don't forget, like I said earlier, 1, 2, 3, 4, 5, 6. There are 6 trigonometric functions. You're going to have to know them, how to work with them for the rest of the chapters. Before we start, we want to figure out what the x values of x, y, and r is. You notice I put y there and then r there, because by definition sine of the angle is y over r. So that's my y value, the 12, and that's my x value. My r value, 13. What's the second step we did? We did the Pythagorean theorem. X squared plus y squared is equal to r squared. X squared, we don't know what that is, plus y squared, there's my y, square that, you get 144. My r is 13, square that is 169. Subtracting 144, x squared is equal to 25, and x equals plus or minus 5. I'm going to highlight something here. When you take the square root of both sides, you got to put plus or minus. Put that in bold for you guys, just so that, let's do it again. Plus or minus 5. The reason why I have to put plus or minus 5, because I got to know which sign it is, plus or minus. It's in quadrant 1, which means in quadrant 1, x is positive. So you end up with plus 5. That's very, very important, guys. That's the one that's going to give you a hint. That theta is an element of quadrant 1. Or it's going to be, the terminating side is going to be in quadrant 1. So what's the cosine of the angle? We're going to do it right over here. It's x over r. What's my x value? 5 over r, 13. What's the tangent of the angle? It's going to be y over x. So I memorized it. Memorize your ratios, please. Tangent is y over x. Y is 12. X is 5. What's the secant of the angle? It's going to be, secant is the reciprocal of the cosine right there. So it's going to be r over x. What's my r? 13 over 5. And what's my cotangent? It's the reciprocal of the tangent function right there. Since I already have it, it's going to be 5 over 12. And the cosecant of the angle is going to be the reciprocal of the sine, which is 13 over 12.